Alrighty. All right, we're on chapter who? 3. Okay, remember your test. Not next week, but the next week, that Tuesday. We'll cover chapters 1, 2, and 3. If you're not going out and watching the videos that I'm putting out there, and because if you're not getting it, and you're not coming to me, I ain't seen any of you. Well, I mean, seen some of you, but I'm saying, but the people that I've seen, it looks like they understand what they had questions about. But if you have questions, make sure you come and ask your questions. Okay? We're getting ready to get a little rougher, so if you hadn't got that, that's baby stuff. Finna put the gas on. Alright? Oh, Lord. About to die while I'm trying to put the gas on. Alright, so this chapter is going to talk about the big guys, the macromolecules, the carbohydrates, the proteins, the lipids, the nucleic acids. Okay, now, anytime we're talking about something being organic, okay, if it's organic, we're talking about it being living material. So the carbohydrates, the nucleic acids, the proteins, and the lipids. It says all of those are living materials. And every last one of those guys, it says they include carbon. Okay? So carbon is a part of every last one of these guys. Okay? So it says whether the carbohydrate molecules in a bacteria versus the carbohydrate molecules in an animal. It says their sameness and their diversity, okay, all depend upon carbon, okay? But every last one of these molecules that we consider to be living material, it says they all are composed of this carbon. So in other words, they're all going to have a carbon backbone as the base for the molecule. So it says the chemistry of all the different things that we're going to make, it says it's essential. And it's based on this guy who combined how many things at one time? We know. 4. Okay? At least 4 things. And whether we're binding carbon to another carbon or we're binding carbon to a hydrogen, it says this guy has 4 valence electrons and it can bind up to 4 things at any one time. So we can bind it to oxygen. We can bind it, to an oxygen, okay? So hydrogen, fluorine, whatever, all those other guys, and make up all the different types of compounds that we're going to be working with. All right, so bonding of carbon to the hydrogen, the oxygen, the nitrogen, it says they create these organic molecules. If you look on page, see if they give you this in your textbook. Doesn't look like it. Nope, they don't. But if you wanted to compare the difference between things that we consider to be organic and things that we consider to be inorganic, anything that we consider to be living has to have carbon and hydrogen. So it just can't have carbon and oxygen, okay? But it has to have carbon and hydrogen in the molecule in order for it to be considered organic or living material. So if we look at the carbohydrates, we look at the lipids, the nucleic acids, and the proteins, they all contain carbons and hydrogens. If we look at our inorganic things, somebody name something inorganic without looking at your notes. What's inorganic? We're talking about chemicals. Name something that's inorganic. Right, HCl has hydrogen, but does it have the other thing that we said that we needed? Carbon, no. Chlorine is not considered carbon, right? It's chlorine. Okay, so we said every single thing has to have carbon and hydrogen if it's considered to be organic. Somebody name me something else. Right, potassium chloride. He pointed at, pointed at potassium chloride. Water, carbon dioxide, all of those things are inorganic, or what we constitute as non-living molecules. One of the other things that you'll find is that most of your organic molecules are going to bond covalently. So the bonds within it are going to be covalent bonds. So all of these are what? Covalent bonds. Okay? So they have covalent bonds. But many of the inorganic molecules are going to have ionic bonds. Okay? So they're going to have ionic bonds. Many of them. Because most of them are like salts, for example. Usually, if you're talking about something organic, it usually has many atoms inside, or that's making it up. Anytime you're talking about something that's inorganic, usually it's going to have a very little number of atoms to make up the different molecules. So we said organic things, we said contain carbon and hydrogen. We said that they are usually large, have a large number of atoms. How did we say that they bond? Organic. Covalent, okay? And then we said inorganic guys, we said usually a small number of atoms. We said these guys are usually bond which way? Ionically. Good. Okay? And do they contain carbon and hydrogen? Good. So we know we have to have carbon and hydrogen if we're talking about something being organic. All right, so it says every last one of the organic molecules, whether we're talking about a carbohydrate, a lipid, protein, or nucleic acid, it says they all have these carbon chains, and it says they also are going to have something else, but they all have a carbon backbone, some kind of carbon backbone. So it may be a number of carbons linked together. So if it has a carbon chain, we can have a number of these carbons linked together. Okay? And we said we know it's going to have some hydrogen somewhere. It may not cover the whole molecule, but it's going to have to be associated with some carbons. The other big thing about this carbon chain, it says not only will it have the carbon chain, but it's going to have what we call a functional group. So it says living things. I don't care if we're talking about carbohydrates, lipids, proteins, nucleic acids. It says we know sugars fit into which category? Carbohydrates. Fatty acids, which category? Good. Amino acids. Proteins. Nucleotides. Nucleic acids. Good. It says every last one of them have a carbon backbone or skeleton, and it says, but they also have an FG. They have a functional group. They have a functional group. They have a functional group. So we want to talk about, well, what is a functional group? What is a functional group? So functional groups are usually a combination of atoms that basically always bond in the same way, and they always, or they make molecules have a certain characteristic. Okay? So the specific combination of atoms that always react in the same way. So they're specific combination, they bond in a certain way, and they cause a particular reaction. Okay? So a functional group, an FG. Now, your list of functional groups are on page 45. Yes, 45. So make a note, a reference. And they make molecules have or classify them in certain ways as well. So if we were looking at, and I'm only going to make you learn how to draw 4 of those. And the reason why you need to go ahead and learn how to draw the 4 is because you're going to be using the functional groups to create all of these other molecules. One of which he mentioned, which was a triglyceride. Okay? So you're going to learn how to draw triglycerides. You're going to know the difference between a saturated fat and an unsaturated fat. And you will be able to draw a saturated fat versus an unsaturated fat. Okay, so here we go. Functional groups. So we'll start at the beginning. These are the ones that you need to know. One of the things that you see in that chart is the letter R. Everybody see that letter R? What do you think that R means? The rest of, right, so the remainder of the molecule, so whatever it's stuck on, okay? So when you're doing the drawings, you don't have to include the R. You can if you want, but it just means that's whatever it's stuck to, okay? All right. I'm going to draw mine without the R. All right, so we're going to need an OH group. We already should know what an OH group is. Because when we talked about pH, we talked about that OH group. What is it called? Hydroxyl group. Good. So we have hydroxyl groups. All right, now with the hydroxyl group, what does it say in your table about hydroxyl groups? In your book, look at your book. Present in sugars, alcohols, and some amino acids. Good. So it's telling you where they are and what you're going to find them on. Okay? Now, the next one I want you to know is not the carbonyl, but the carboxyl group, which is a C. This is a carbon, right? It is double bonded to an oxygen with this hydroxyl group stuck out to the side. And we can draw that the other way too. So know that depending on where you're putting it, you might draw it in this configuration, or you might flip it around and draw it in this configuration. So, you know, it depends on where you're sticking it. You know, if the rest of the molecule's here, or if the rest of the molecule's there. Okay? So this is your carboxyl group. Same thing with that guy. You know, you can flip it around and same thing. It's a carboxyl group. Carboxyl. Okay, that's an O. Okay, so this is what I want you to have. Carboxyl group.
Okay, so
Yes.
the structure that they give in this table,
Mm-hmm.
are those what we are to learn to draw, or how you're putting it up?
Putting up on the board.
Okay, so the first one, okay, is for hydroxyl.
Mm-hmm.
So you're going to start writing the other on the next slide, because I can't see that.
You can't see past what?
I mean, I can see down to the carboxyls, but if you go lower, I'll miss it.
Well, I had to draw the other one. It's the same thing. Only thing I did was show that you could draw it in more than one. You might want to come to the front. No, sit right next. Yeah, you need to come sit here. But anyway. Right. Well, it just depends on which end of the molecule you're putting it on where you may have to flip it around from one side to the other side. Does that make sense?
Yes.
All right. All right, so we said this was a carboxyl group. Now I'm definitely going to draw your phosphate group differently too, okay? And the amino group. The amino group, depending on whether it's ionized, not ionized, all that, it can change. You know, we can go from an NH3 to an NH2. We're going to do an NH2. Cool beans? All right, here we go. One of the other things that your book is also showing you is structure, the exact structure. I'm showing you easy way so you'll get it right on the test. So the things will be pointing where they need to be pointing so you'll know what to take away when we actually start doing reactions. Okay? So I'm showing you the easy way. Next one, amino group. New marker. So we got an amino group, so it's an NH2 group. So we got an H and we got an H. Here's the end of the molecule. Or we can do what? Flip that around and go that way. So if the molecule, did I do something twice? Y'all forgive me. But usually if you're doing a protein, you make an amino acid, so in most instances, that amino group is always going to be on your left, okay? Especially if you're doing a protein. The amino acid is always going to be on the left. It'll never be on the right. Okay? All right, so that's an amino group, AMINO group. So the amino group. And then the last thing that you would need to draw, and I think your book shows it ionized, let's see, partially. All right. We want a P, which is a phosphate group. Remember, we didn't want to confuse phosphorus with phosphate. If you write phosphate, if it asks you for the most common atoms, somebody tell me what they are. What are the most common atoms? Carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. This is not this. Yeah, chnops, correct. Okay? And we could even go ahead and make this. It just shows you that it was connected to that R, whatever. So we can draw it like that for now. Okay, so that's a phosphate group. Alrighty, here we go. Make sure you practice drawing those. Now, when you go into you got a folder that's called Integrity Classes. And in that folder, you'll find videos that show you how to do all the types of bonds. It shows you how to draw a Bohr model. It shows you, a lot of that stuff. So if you're not getting it, you need to be in that folder. And then when you've gone to that folder and you still don't get it, you need to be yelling at me. Hey, excuse me, help me. Okay? All right, here we go. The carbohydrates, first one we're going to talk about. Includes your sugars, your starches, and the fiber. The doc is telling you to make sure that you include in your diet. So the sugars, the starches, and the fiber. Anytime we look at a carbohydrate, it says we have a ratio of carbon to hydrogen to oxygen of a 1 to 2 to 1 ratio. So it says our ratio of carbon to hydrogen to oxygen will always be, or most instances be, in a 1 to 2 to 1 ratio. Anybody know the empirical formula for glucose? C6, H12, O6. Is this a 1 to 2 to 1 ratio? Yes. If I divide through by 6, 6 into 6, I get what? 6 into 12, I get what? 6 into 6 again, I get what? So we are in a 1 to 2 to 1 ratio. Now, the typical forms that we can find. Monosaccharides. Mono meaning what kind of sugar? It's a single sugar, good. So 1, mono meaning 1. We also will find disaccharides. Di meaning 2. And then finally, the monosaccharides, we already know that's the quickest form of sugar that's going to move quickly into the bloodstream. Disaccharides, we know that we're going to have to break some bonds in order to utilize that sugar. Usually the way it's transported in plants. And then we can also have polysaccharides. Polysaccharides, usually they're either going to play some kind of structural role, or it may be a storage form of glucose, okay, like in starches. We can just link many of these glucoses together and they form a starch. Or we can link many glucose molecules together and they make fiber. That's more of a structural molecule that we find in plants, for example. And then we'll talk about, the difference between kind of the glucose polysaccharides that we find in plants versus the ones that we'll find inside of us that the liver is going to be responsible for helping to form. All righty? So a monosaccharide. Here we go. Now I hate that some of y'all hadn't really been playing and getting that stuff down, because I'm sorry. I'm apologizing in advance for those of you who hadn't been playing online. Okay? All right. So it says monosaccharides, we know, are single sugars. Your quick source of energy, because it's going to move right into the bloodstream, okay, and raise glucose, and then send out signals that, hey, our sugar level is up. We need to give the cell some energy, okay? So then the insulin will be released in order to restore that sugar level back where it's supposed to be. But this is the guy that's going to go in there pretty quickly. It says the empirical formula, which was given earlier, was C6H12O6. C6H12O6. It says some of the forms, it says, that are transported in the blood of animals, we know we said was glucose. Okay? Or if we looked at one that's comprised in DNA or RNA, then that's going to be deoxyribose and ribose. So those are also single sugars. But these guys are the ones that are responsible for making up a nucleotide. Okay? Deoxyribose, we know we'll find in which one? DNA. Ribonucleic acid would have which one? Ribose. Good. All right. In order for us to start generating these molecules, the disaccharides and the polysaccharides, we need to know how to draw glucose. Okay? We're not going to use this form, but remember when we talked about isomers, what's an isomer? What's an isomer? Molecules that have different what? Yes, same empirical formula, different structure. Good. 1, 2. Don't draw this what I'm drawing over here. 1, 2, 3, 4, 5, 6. Okay, this is an isomer of glucose. And these, I've got my bonds in between the carbons. And these guys can flip around and make even more. There's so many isomers of glucose that make your head spin. But anyway, that's an isomer of glucose. The one that we're going to use is the ringed form, where this part of the molecule comes around and joins with, this one. So it comes around, joins with that one, and he hangs off. All right, here we go. Now, one of the things that you'll never see are the carbons. Okay, so at every corner, except for that one, because that's where the ring join, there's a carbon, okay? There's a carbon. There's a carbon. It's understood. You do not have to write it, okay? But the other thing that we see are what? Hydrogens, and then what? Hydroxyl group. Because we said hydroxyl groups make what? Sugars, right? Okay, so everybody okay right now? Okay? So at every corner, we know that we're going to have a what hanging off? A hydrogen and a who? Hydroxyl. Huh? No negative. Just O, H, or whatever. Now, this is the key with the hydroxyl groups. The oxygen portion of the hydroxyl group always has to be attached to the stick, which the stick represents the what? The bond. Beautiful. The covalent bond. All right. So, now, so we're going to have always a HO and an O. We're going to start with the HO, and we're going to end with an O. Okay? Everybody got that? We're going to start with a HO, because I said, right, okay? We're going to start with a HO, and we're going to end with a who? O. So we'll start with the HO, and we're going to end with an O. Got it? So then we know that on the other side of that carbon is a what? No hydrogen. So both of these are going to have hydrogens. Okay? Now, the next placement is going to be the same, but this one's going to be a little bit different. Because this is way down here, we're going to put, again, the hydrogen and the hydroxyl group. And then we're going to put a hydrogen, a hydroxyl group at the top and the hydrogen at the bottom this time, okay? And the reason why this flips is because they're trying to move this out of the same plane with that, so it flips up into there, okay? And then this is a hydrogen understood. We don't want to fool with that. We don't have to put it on. But what we want to end this off with, which is what's sticking off the top here, because remember we said this is going to swing around, bond here, this is going to be hanging off of that carbon. So at the top we're going to have a CH2OH. I'm going to prove it to you. CH1H2 OH. Cool beans? All right. This is alpha glucose. You need to know this. It's called alpha glucose.
This drawing is alpha glucose?
Yes.
So, with all of the O's and O's and what we have up there, it's equivalent to the chart you drew on the other board?
Correct. But in a ring form.
Right.
Correct.
So if you were to look at that and read across upward, I would think, since you ended with the C.
H2.
So if you read up like that and we can figure it out over there, they should coincide.
Right. Except for you're going to lose the hydrogen because of the bond. Okay? All right, so this is the guy you need to become very familiar with. Yes? Yes, with that hand up? Okay. Yes. No. This is what you need to know right there. That's it. I want you to know that because you're going to use the heck out of this. All right, so what functional group makes sugars? Hydroxyl groups. They also make things what? Dissolving with the sugar dissolving water. So that means that this guy is what? Soluble. What other word I'm looking for? Polar. All these hydrogens and oxygens is making this polar, okay? So he's also polar. That's why water is able to solvate it and put it in the solution. Okay? So I'm gonna move this in a minute. Y'all ready? All right, we're getting ready to do our first reaction. All right, I'm ready. Y'all ready? All right, here we go. All right, so it says, we want to make a disaccharide. For those of you who drink beer, maltose is a sugar that is used in beer making. It consists of 2 subunits of glucose. We want to always refer to our subunits as monomers. I don't care if you're talking about a monomer of an amino acid. Anytime you're talking about one little piece, it's a monomer. Okay? So in other words, if I wanted to make a polymer, I'm going to do what? If I wanted to make a polysaccharide, what would I do? Several of them, right? 3 or more. But if I want to make a disaccharide, how many I need to put together? 2. And if anybody needs clarification after class, please, or if you need clarification while we're going along, just make sure you ask, but don't leave here and you're still confused. And, I mean, you know, you got to practice if you want this to work out. All right, here we go. So we're going to make a disaccharide. The way we're going to make a disaccharide, we're going to do something that's called, and probably you read about it in your book. What kind of reaction? Anybody remember seeing that? Yes, a dehydration synthesis reaction. Okay? So in a dehydration synthesis reaction, it says, I'm going to do what? What does dehydrate mean? I'm going to take away water. Okay? So what do I need here? A what? Right. The hydroxyl group. We call her a hoe or him, whichever. Okay, so we got a hoe and an O. All right, and then we got to have what at the top? What's this? Good. CH2OH. Above each hydroxyl group, what do I need? Good. Hydrogen. Lovely. And then down here, what am I going to put? Good. Hydroxyl group. What am I putting up there? What am I putting up there? Hydroxyl group. Correct. And then on opposite each one of these, I'm going to put a what? A hydrogen. Good. All right. So it says I need to add these together. So I need a plus sign. And I'm going to draw the exact same alpha glucose as I did before. Because it says I need two of them. And you're going to draw everything in the same place. Look at where this oxygen is. It's always going to be in the same place. You're not going to flip it back in that other direction. It's always going to be going this way. So I've got my OH, I've got a hydrogen, got a C, H2OH group. Okay? Now, it says I need to label these guys. Oh, you can't see. I need to label these guys, so I want to put glucose, or I can write the word monosaccharide. You like glucose real nice and short, isn't it? I think I spelled that right, but I'm not sure. Okay, so we're saying glucose plus glucose. And it says we're going to follow this with a dehydration synthesis reaction. So you told me that the word dehydrate meant to remove water. But in order for me to make water, I have to remove now look, our enzyme is going to come in here. This is feasible, right? And he's going to take away a hydroxyl group and what else? And a hydrogen. So he's not going to take this whole thing over here. He's just going to take that hydrogen. And that's going to make what? H1, H2, O. Okay? So he's going to take that away. Now, when we take away water, we form a covalent bond. The enzyme's going to help us make that bond. But before we make the bond, we got to start drawing from here, and we got to do something here. It makes it what we call an oxygen bridge. All right, so we got, sorry, I didn't leave myself much room over here at the end. All right, so we got our hydroxyl group, we got a hydrogen, we got the C, H2OH. Okay, we got a hydroxyl group, we got a hydrogen, but something happened here. Did we remove these guys? Yes or no? No, they're still there, so we want to put them there. Okay, and I'm going to draw the end of my other molecule. If you in this class, yes sir, seriously. At the end, did we take anything away? No. So we still got to put this hydrogen here and this functional group, the hydroxyl group. We got a hydrogen, a hydroxyl group, we got a hydroxyl group, and we got a hydrogen. The type of bond that forms between these two, and I kind of messed that up as far as like my drawing. Let me bring that down a little bit. There we go. Still kind of bad. All right. It says, what was left here? Somebody tell me what's left. O, that's it. And it creates a bridge between the two. So here we have the O. You okay? Yes, sweetie.
Is this the same drawing on page 47, but you're still getting all the blanks?
Yes.
Right here, right?
Yes. Correct. At the bottom of page 47, you have the same thing. The key is, it says we got to take away who? Water. We got to take away a what? Hydroxyl group and a hydrogen. We form what kind of bond? Glycosidic bond, which is a covalent bond, and the glycosidic bond are characteristic of all carbohydrates. Every last one of the carbohydrates will have a what? Glycosidic bond. The nickname for it is oxygen bridge.
Can you say that? What type of bond that was?
Glycosidic. Glyco. C. Yeah. Glycosidic. Glycosidic. Yes, ma'am. Every carbohydrate. Yes, ma'am.
It's a covalent bond.
I mean, it is, that's what kind, the bond, no, these are covalent, every last one of these lines represents a covalent bond.
Okay.
Okay? Got it? So what? And look, let me tell you this, gang. I will put this online, me drawing. Yes, sir. Yes, I haven't put it on yet. I got to label and put it on. Correct. No, we could, well, say for instance, let me say this. We won't just create a disaccharide. We're going to create glycogen, okay? And glycogen is a polymer. But we're just going to take those glucose and keep linking them on. And make sense? And that's where we store the polysaccharide is in our liver. We also store a little bit of glycogen in our muscles too for those quick, yeah. But the majority of it is stored in the liver. But right, and we won't make a disaccharide. All right, so we want to put on this side disaccharide or maltose, okay? I put maltose at the top. Maltose. We said, or it's a what? Disaccharide. The thing that I left off that you shouldn't forget to leave off is what? Water. We took it away, it didn't disappear, but I ran out of room down here, so plus, you'd put plus, and I want to write on the wall, H2O. Okay? Yes, ma'am. No. Just know it was enzyme that did it.
What is the name of the enzyme?
I'm not particularly sure since we're not saying exactly what we're creating. Okay? A maltase. Okay? But that's part of the enzyme that breaks it down though. Huh? Yes. Yes, correct. All right. It is almost time to go. Let me tell you what, but I'm not done. It is very important. Are y'all listening? And I'm talking about extremely important. How many people still want to make an A? Right. What do you think you have to do? All right, let me tell you this. I'm putting it, right, 120. All right, look. I'm putting a quiz online. It is up to you to look for it and to figure out when it's going to show up, because I don't even know. But it'll be sometime between now and the next time I see you. So that means you're going to be looking frequently. And most likely there's going to be some references to those freaking videos that are online for you to watch. Okay? So y'all need to do something so I don't see quizzes that look like what's up there on my freaking table. Okay? So y'all need to go back to the drawing. Now I ain't talking about everybody, because some of y'all been doing what you're supposed to be doing. You know what I'm saying? Some of y'all hadn't. Yes. Oh, I thought you said something. Okay. So for real, y'all gotta, if you want an A, you gotta earn the A. Cause I'm not gonna, give you an F if you don't deserve one. Alright, last thing on this. Y'all, I'm not done. Hold up, hold your horses. Hold your horses. Alright. I need y'all to be quiet, I hear a bunch of talking. Alright, it said, that we can break this apart. Now, let me ask you one quick question. If we went back to chapter 1, I think it was, and we said there were different forms of metabolism. What's the first kind? Beautiful. Anabolism. So then that would make, if we're going to break this guy down, this is what? Right, catabolism. All right, so we want to say that we want to perform a reaction that's a what? What do you think this reaction is going to be called? Hydrolysis. The word hydro means water. The word lysis means to do what? Split. So it says we're going to split water. So here's the water over here. It says we're going to split it. We're going to perform hydrolysis on this. We're going to split water into two things. What are the two things that we're going to split water into? Hydroxyl group and a hydrogen. So it says we split water, we get a hydroxyl group, we get a hydrogen. It says we're going to put them back. Hope I'm drawing the right one to the right one, yeah. So we put them back. And we said this was called hydrolysis. It's a catabolic reaction. So the enzyme is going to come in here, it's going to break water, and we're going to put those two guys back. We said in this way it's anabolism, that way it's catabolism. I'm done for today. Oh, wait, but y'all still can't leave because I didn't send the roll sheet. I do apologize. So while I'm waiting on the roll sheet to go around the room, yes, the lines are a bond. All right, real quick. Stay in your seat. The roll sheet is coming. Y'all sign fast if you don't, but I need to be able to read it. All right, can y'all be quiet for a minute? Do y'all have any questions? Is anybody lost? Stay after class. All right? All right, so for those of you who need to know how to do, we have our first study session today. And help clean up, for those of you who need help is what I'm saying, and got the time to help clean up some of the stuff out of those previous chapters before we get to this stuff. Because everybody needs to know how to do that stuff up front before you dig into this. Don't forget, integrity videos. There will be a quiz online this weekend. Don't know when. Cool beans? All right, rollers coming around. I apologize. How come somebody didn't say, Miss Ewan, the roll? Huh? Y'all too busy learning. I like that. Thank you, ma'am. When you come back to this class, though, you should know how to draw a polysaccharide from scratch, meaning that you'd have to, and at least, hey, y'all listening? That's homework. I hope y'all getting it.
Well, what's that part
That was a disaccharide. When you come back, you have a quiz on a poly. Yes, from scratch. I did a die. You should know how to do a poly. Die in the video, probably. But I'm saying you should know how to do a poly. Poly's easy. Poly means 3 or more. Correct.
We got this.
They just asked, if I'm going to draw a poly, does that mean that the only thing I'm doing is adding one more on that original link? That is correct.